First question, this is the question. According to this, the set S has been given to us, which is 1 2 3 4 5 6, and we need to find the number of onto functions which are, we need to find the probability of the number of onto function such from the set S to S such that g of 3 is equal to 2 times g of 1. So these are the two sets, and here first of all the favorable outcomes to calculate, I need such that g of 3 upon g of 1 will come to be 2 from this. And so according, why this question has mentioned only onto function, the probability of onto function, this is because it wants to make us clear that all the elements in the code main will have a image in the domain. So we can, because g of something, f of something, this means the image, so it wants to make us sure that one image is possible. So we want to get 2, so that from 1 2 3 4 5 6 that is possible when we divide 2 by 1, 4 by 2 or 6 by 3, then we are getting 2. So that means there are 3 pairs of favorable outcomes such that we are getting the onto function and our criteria is getting satisfied. So now when we have chosen these 3 pairs, that suppose one we are getting g of 1 and g of 1 I am taking 1 and g of 3 I am taking 2. So that means some element from here will be g of 1 will be 1 and g of 3 will be 2. So that means in the first pair 2 elements have already been given the we have given them the mapping, and remaining 4 elements are left. So now it is to be an onto function, so the first 2 elements have already been assigned their element in the domain, so pre-image in the domain. So for the rest of the 4, they cannot again pair with the 1 or 3, because they have already been paired with 1 and 2, because if one element in the domain has 2 images, then it won't be a function. So these 4 remaining elements need to pair with some other elements, and that can be done in 4 factorial. That 4 factorial functions can be possible for the pairing. Suppose we are having n elements in one set and n elements in other, so the number of possible functions is n factorial. So 4 factorial functions are possible, and because there were 3 pairs, so for individually 4 factorial, 4 factorial, 4 factorial functions are possible. So when we are considering our favorable criteria g of 3 equal to 2 times g of 1, 4 elements were being left, so that made their functions be 4 factorial. But since there were 3 pairs possible for our favorable criteria, 3 into 4 factorial will be a number of the favorable outcomes. Upon the total possible outcomes will be 6 factorial, because since there are 6 elements in total, so in both the individual sets, so 6 factorial functions are possible. So upon 6 factorial, so this comes out to 1 by 10, which is the final answer. This is the next question. So the reaction involved here is zinc amalgam with HCl, which is our Clemmensen reduction, which converts the carbonyl compounds to alkane. So here CHO will be converted to CH3 alkane, and CH3 will be converted to CH2CH3, which is the answer. This is our next question. C1 and C2 are two hollow concentric cube enclosing charges 2q and 3q. So ratio flux 5 1 upon 5 2. As we know, flux encloses q upon epsilon 0. Flux enclosed in the first cube is 2q upon epsilon, but in the second cube, the 2q of the first and 3q of the second cube, so 2q plus 3q upon epsilon 0. So 2 by 5 will be the final answer. Thank you.